Hello students, welcome to the 7th video lecture of Electrostats chapter number 1. In this video lecture we'll proceed with continuous charge distribution. What is continuous charge distribution? A system of closely spaced charges is said to form a continuous charge distribution. If charges are placed very close to each other, then the distribution of charges are said to be continuous, closely spaced. Okay. Before this, this is the definition of point charge, which we have already discussed in the last video sessions. Any charge which covers a space with dimensions much less than its distance away from an observation point can be considered a point charge. Clear? So now, for what purpose the continuous charge distribution is used? It is useful to consider the density of a charge distribution as we do for density of solid, liquid, gas, etc. Right? So there are three types of continuous charge distribution. Let's proceed with the first type, line or linear charge distribution, in which we calculate the line charge density. Okay, if the charge is distributed over a straight line or over the circumference of a circle or over the edge of a cuboid, etc., then the distribution is called linear charge distribution. Right? Means if the charge is distributed linearly along a line, either it's a straight line or circumference of the circle or edge of the cuboid, everywhere we find this line movement. So there we'll calculate the linear charge density or line charge density, and that distribution is called as linear charge distribution. Right? Okay. Now, what is linear charge density? Linear charge density is defined as charge per unit length, that is lambda. Lambda is linear charge density. It is the denotation of linear charge density. So lambda is equal to Q by L, charge per unit length. If we choose a small section on the line, see this line, the positive charges are distributed along a straight line. We choose a very small length on this line. Definitely this length will be dl. If the total length of the line is L, then this small length will be dl. Therefore, the charge in this particular region will be dq. So lambda is equal to dq by dl. Therefore, the total charge on the line q will be equal to line integral of lambda dl. So this is the description of linear charge density, okay, or linear charge distribution. Right? Next, the new one is surface charge density. Okay, what is surface charge density? If the charge is distributed over a surface, charges are closely spaced over a surface, then distribution is called surface charge distribution. Right? In the surface charge distribution, we calculate the surface charge density, and surface charge density is sigma. Denoted by what? Sigma. Sigma is equal to Q by S, charge per unit area. And if we suppose over this area the charges are being distributed like this, then we choose a very small area ds. The charge will be what? dq. If the total charge is q, then over this small area the charge will be dq. Therefore, sigma will be equal to dq by ds. If we calculate the total charge q, then surface integral of sigma ds will be the total charge. Okay. Do remember that SI unit would be coulomb per meter square, of which one? Surface charge density. And linear charge density SI unit would be coulomb per meter, because here it was length. So therefore coulomb per meter. Next, volume charge density. Volume charge density is denoted by rho. Okay, if the charges are being distributed over the volume, throughout the volume of a conductor, okay, or any body, then this is called as volume charge distribution, if they are closely spaced like this. So therefore we calculate the volume charge density. Volume charge density rho is equal to charge per unit volume. Okay, so charge per unit volume can also be represented as dq by d tau, if that tau is the volume. So if we choose a small section, here we can write v also, dv or q by v. If we choose a small section, then definitely it would be what? dV. So rho will be equal to what? dq by dV. So net charge, or we can say total charge on volume V would be equal to Q is equal to volume integral of rho dV. So this is the description of volume charge distribution. Keep it in your mind that there are three kinds of charge distribution: linear charge distribution, surface charge distribution, and volume charge distribution. And three kinds of charge densities are there: linear charge density, volume charge density, and surface charge density. Thank you for paying attention in this video session. We will meet again in the next video session with the next topic.